Good morning, my dear students. In the last lecture, we have discussed regarding the magnetic properties. Means every magnet it has got its own what is the properties. What are the important properties a magnet exhibits? Those in detail we have discussed in the last class. Like the magnetic dipole means what? Magnetic dipole moment. Next is the magnetic field, magnetic intensity, and magnetic potential. Then what are the basic definitions? And in some of the cases, there are what it is the having the some important formula like magnetic intensity at any point due to a magnetic pole. The next, the what is the definition of the magnetic potential? All those points we have discussed in the last class. Now today, let us go to the with the what it is the help of these definitions. Now we are going to derive the what it is the formulas. Then one formula is what it is the magnetic intensity on the axial line of a dipole. Now first let us try to understand to which we call it as a axial line. Now all of you what it is carefully what look at towards the board. Now for example, let us say this is a magnet. Is it a north pole and this is the south pole and this is the center. The line which is passing through the poles and the center of the magnet. This is called as the axial. Is it? What it is? The line passing through the two poles and the center of the magnet, that is called as the axial line. Is it? Now, at any point on the axial line, what is the magnetic intensity? Is it? Now, if there is a magnet, means that produces a magnetic field, and what is the magnetic intensity? All those definitions we have discussed in the last class. Now, suppose this is any point on the axial line, then at this point there is some magnetic intensity is there. Then if there is a magnetic intensity means then how much magnetic intensity it is there. To calculate that we require some formula. Then let us what to derive that what is the particular formula for this one. Now the next point is in the derivation of this one. What are the important points will come across? Then first I want to make it clear those points. Isn't it? Now one is here the if you take any point on the axial line, always we what it is the measure the distances from the what it is the center. Isn't it this one? And the next point is here in the last class we have discussed that for example this is a magnetic pole of pole strength M. Is it? Magnetic pole of pole strength what is the M. And this is any point P, is it? Which is at a distance of D from the pole. Is it? This point P is at a distance of D from the pole. Then at this point, then what is the magnetic intensity it is there due to this pole? Then that formula is yesterday we have discussed it. This is B. It is equal to mu naught divided by 4 pi M divided by D square. Isn't it? Now see, this is the formula of the magnetic intensity at any point due to what it is the A pole. Now, if this is a point P which is at a distance of D from this pole of pole strength what is the M, then intensity at this point due to this pole is B is equal to mu naught divided by 4 pi M divided by D square. What is this D? D is the distance of the point from the pole. Now, with the help of what is this one, the next one more point what we come across is, yes, you know that the magnetic intensity or magnetic field, this is a vector, is it? Means which has got magnitude as well as the direction, is it? Magnitude can be calculated by using this formula. Magnitude means value. It is 20, 30, 40, like this it is. Then magnitude. Then what about its direction? Now here, the direction of the intensity it is that if it is a north pole, is it? Intensity due to the north pole is away from it, is it? Away from it. Now, if it is a south pole, is it? Intensity due to the south pole is towards the pole. Now, for example, here this is a north pole and this is a south pole. Is it? If you take any point here, then at this what is the point? There is what is the two magnetic intensities are there. One is due to the north pole, another is due to the south pole. Is it? Then, since this is the north pole, then the magnetic intensity at P due to the north pole, it is away from it. Away from it is in this direction. This is the BN. Means intensity due to the north pole is away from the north pole. And due to the south pole is towards it. That means then this what is the direction yes is what towards. Now these are what is the important points what we come across in the derivation of this formula of the magnetic intensity on the axial line of a dipole. First point is, what is the axial line? Means a line passing through the two poles and the center of the magnet. This one, isn't it? Next is the magnetic intensity at any point due to a what is the magnetic pole formula is this one, isn't it? And the magnetic intensity, it is a vector, means it has got magnitude as well as the direction, isn't it? The magnitude is this one, direction is, if it is what is the north pole, intensity due to the north pole is away from it and intensity due to the south pole is towards it, isn't it? I hope with the help of these important points, now you can understand very easily the what is the formula of the magnetic intensity at any point, isn't it, on the axial end of it, what is the dipole. Now, carefully you see here, let us consider this is a what is the magnetic dipole, isn't it? Magnetic dipole, isn't it? And of what is the pole strength, how much it is the M? M is the pole strength, isn't it? And magnetic length is what it is a 2L, isn't it? Now let us consider P is what it is at any point and the axial line. P is any point on the axial line which is at a distance of D from the center of the magnet, isn't it? Point P is at a distance of D from the center of the magnet. It is. Now, we also have to do that at this point, isn't it? At this point P, there are two what is the magnetic intensities are acting. One is due to the north pole, another is due to the south pole. Now, what is the formula of the magnetic intensity due to any pole is what it is the basic formula is mu naught divided by 4 pi, isn't it? Then it is equal to how much it is? Mu naught divided by 4 pi into M, isn't it? Divided by, isn't it? Then here, first, let us make it clear here. Then field due to a pole is what is the formula is what, isn't it? B is equal to, B is equal to mu naught divided by 4 pi, isn't it? M divided by D square, isn't it? M divided by the D square. Now M is what it is the pole strength and D is what it is the distance of the point from the pole. Distance of the point from the pole. Now, let us into the first here field, but due to, isn't it, north pole, isn't it, north pole, Pn, it is equal to, formula is what, mu naught divided by 4 pi as it is, mu naught divided by 4 pi, and next, M divided by, then D square is what? This D is what distance of the point from the pole. Now, since we are finding the field due to the north pole, therefore, here you have to take the distance of this point from this pole. Here this distance it is equal to, this distance is equal to, then this distance D minus of this one, isn't it? Now this total distance is 2L. And it will become as a L. Therefore, this distance, isn't it? Distance of the point from the pole, this is equal to this D minus of L, isn't it? Therefore, that I write D minus of L. Square the distances. Therefore, it is the field due to the north. Field due to what is the south pole? South pole, let us write Bs is equal to mu naught divided by 4 pi, isn't it? But pole strength is same for both what is the north pole and south pole. Now, what a field at this point due to this is south pole, it is equal to, then this we have written it mu naught by 4 pi and M pole strength of this is also be M divided by square of the distance means you have to take this distance, total distance. Okay. Now this distance, it is equal to this distance is how much? It is d plus this one. It means this distance, it is equal to how much? It is the n. Therefore, here we write it is d plus n. Square of the distance is d. This is what it is. Therefore, this one is the field at this point due to the north pole. Next, this one is what is the field at the same point due to the south. Now, we are already clear that this what is the one? It is a vector, which has got the direction also. Then field due to the north pole is away from it. That is what the Bn is in this direction. Now, next is field due to the south pole. The Bs is towards the pole. The south pole, it is the towards. Now here, this what is the field due to the north pole and field due to the south pole, they are in the opposite direction. Hence, the resultant what is the field is this right as R, resultant field. Now, yes, already you have studied in your lower classes that if the two vectors are along the same direction, then resultant value is equal to sum of those two. Now let us consider if this is one vector and this is the another. Then let us say this is what is the A bar and this is B bar. Then resultant R bar is equal to what we write here? A bar plus B bar. If they are in the same what it is the direction. Now instead of this one, if they are in the opposite direction, let us say this is A bar and this is B bar. If they are in the opposite direction, then the resultant is equal to difference of these two, A bar minus of B bar. Like now, this is what we are applying this concept. Now here, field due to the north pole and field due to the south pole, they are in the opposite direction. Hence, the resultant field is equal to difference of these two, isn't it? That is Bn minus of Bs. Next, now substitute this value. Bn is equal to mu naught by 4 pi m divided by d square minus of L square, and this is what it is the then Bs is equal to mu naught by 4 pi m divided by this one. Isn't it? This unit. Now what you do is in this one, whatever the common factors are there that you take out here, that is common or mu naught by 4 pi m, it is a common. Then remaining is 1 divided by of this one, minus here this is there. Now what you do is you take the LCM, now product of these two is LCM you get, then you will get it here this much, Now here what you do is then this is D minus L and this is D plus L. Then power is same for this one. This is the square and this is the square. So that you can write this one as how means this mu naught by 4 pi m as it is. Then here, since they are having the same power means, then you can write then D minus L, D plus L whole square is. That means then you will better. I will write this one in this case like this. That is D minus L, or D plus L. Are having the same power, that is the length, right? This one, and here it is like A plus B whole square. What we type, then this D square, this will get minus of here D minus of L whole square. You will get this much, Next, here this is as it is, and in this case it is like A plus B into A minus B is what A square minus B square form, and its power is 42, you will get this one. Alright. Next, here this is as it is theoretically. When you set this what is the minus sign inside this one, then you will get it here minus B square minus L square minus of minus you will get here plus. This is what you will get here. Now here what will happen is this D square this will get cancelled and this will get cancelled. Now what you left here? Plus 2L plus 2L is 4. What is the DL you will get? Then divided by this is what you get it here. Now this what is the again you simplify this one. Now you get it this as mu naught divided by 4 pi. Now I can write this as 4 is there. Then I will write what means 2 into 2, this is 2 into 2 m, what is the d into l, 2 m d into l divided by this d. Now this is as it is, d square minus of l square whole square. Okay. Now this is equal to here mu naught divided by 4 pi. 2 you write as it is, isn't it? And this you can write it here as what is the 2 L m into d. Just I have rearranged terms, isn't it? Divided by this d square minus of L square, isn't it? Now, after understanding up to here, now let us come to now just I will arrange this one. This this is equal to then mu naught divided by 4 pi. Yes, I will write it as it is, and what I will write as it is. Then next is 2L into m. It is what it is the product of pole strength and magnetic length is nothing but it is the magnetic moment, isn't it? So that I will write it here as this is capital M, isn't it? Then into d divided by what we get it here d square minus m square whole square it is. Then here, yes, you know that capital M is equal to what? 2L into M. That is the product of pole strength and magnetic length. 2L is the magnetic moment. That is what I have written. This is what the resultant is it a magnetic field on the axial line, so that we write it as what is the A. Isn't it? Then this was the formula of the field or intensity, magnetic intensity at any point on the axial line of what it is a magnetic dipole, isn't it? Now, in this one, all the factors are known to you, isn't it? Then this mu naught divided by 4 pi, it is a constant. To m is what? It is a magnetic moment, isn't it? Then small d is what? It is the distance of the point from the center of the magnet, isn't it? Distance of the point from the center of the magnet, and divided by this what d is again distance of the point from the center of the magnet, and this L is what it is the semi-magnetic length, isn't it? That is total magnetic length. It is represented by what? It is a 2L, and L is nothing but it is a semi-magnetic length. If you know all this thing, then very easily you can calculate what is the magnetic intensity at any point on the axial line of a what is the magnetic dipole. Now, here some special case is that one here special case is that actually the L value it is very much less than what is the D. All of you what it is has seen a bar magnet in the physics laboratory. You have done the experiment, isn't it? I remember that the frequency of AC, isn't it? In that experiment, you are using a bar magnet, isn't it? Then all of you have observed that this is size of this is this one, isn't it? And D is the distance of the point from the center. D. Therefore, what will happen is D value or D value it is very much greater than L. Otherwise, the same thing you can write it as L is very much less than what is the D, isn't it? Now, special case that now here for a short magnet, short magnet means then for a short magnet is nothing but that is L is very much less than what is the D. L is very much less than D. Then when you apply what is the this, what is the concept, is it to this formula? Let's see. This formula reduces to what? Then here, when you simplify this one, BA it is equal to, again I will write this one 4 pi, it is 2 what is the M D divided by this D square minus of L square, what is the whole square. See, this is equal to mu naught divided by 4 pi. This is 2 M D divided by. Now what you do is here you what a d square you take out of the bracket. Out of the bracket. Now here already d square is there and square means you will get d raised to 4, correct? This one. And here you will have with 1, isn't it? Next minus half, isn't it? Minus half. Here you will get L square divided by what? D square. This is what you get here. This is half bracket, isn't it? Now this formula reduces to this one, isn't it? Now what will happen is, since, isn't it, L is very much less than D, isn't it? Now the numerator is very small, means it's what it is the value and divided by D square. D is very much greater than L. That means this factor will become negligible, isn't it? Then what will happen is, here L square divided by D square, it is approximately equal to 0, isn't it? Why is? Because L is very much less than D. Numerator value, it is very much less than the denominator. Then the fraction will become as negligible. Negligible means always we consider it equal to 0. Now, when this will be 0, you will have only 1, then 1 square means you will get 1 only. Now, this formula, it what reduces to, you will get it here, dA, it is equal to mu naught divided by 4 pi, it is 2m, what is the d, divided by, you will get what the d raised to 4, and this will get cancelled, you will get what dq. Now, this is equal to what it is, this dA is equal to mu naught divided by 4 pi, this is 2m divided by dq. Now, so this is the formula of the magnetic intensity, isn't it? At any point on the axial line of a dipole, isn't it? Then in this one, all the factors are familiar to you. This is the constant. M is what? Capital M. It is the magnetic moment. And d is what? It is the distance of the point from the center of the magnet, isn't it? Now, then this is the what is the special case. That means when we have to apply this formula, we have to apply this formula for a what is the short magnet, isn't it? Now, you see, in case of the problems, isn't it? Then how to get the idea that whether we have to use this formula or this formula means, in any problem, listen here, if length of the magnet is given to you, isn't it? In the problem, if the length of the magnet is given to you, in such cases you have to use this one, isn't it? Now, in some cases, if the length of the magnet is not given, then it is understood that it is a short magnet, isn't it? Then you have to use this one, isn't it? Therefore, either by using this formula or by using this formula, you can calculate what is the magnetic intensity at any point on the axial line of a dipole. I think this what it is the derivation is what is the clear to you, isn't it? Now see, after understanding what is this one, now we are having the one more derivation, that is the field, what is the formula of the intensity of the magnetic field at a point on the what is the equatorial line of the what it is a dipole. Now, before going to derive what it is the this one, now let us try to understand first what is the equatorial line, isn't it? Then we'll go for the derivation of what it is this one, isn't it? Now let us try to understand first, isn't it, about what it is what is the equatorial line of what it is the dipole, isn't it? Now, just now we have discussed regarding the derivation of the field along the axial line of a dipole. Now, let us come to the what is the formula of the field at any point on the equatorial line of a dipole. Now, before that, let us try to understand to which we call it as the equatorial line, isn't it? Now, let us consider this is a magnet, this is a bar magnet, and this is the center of the magnet. Then this is the north pole and south pole. Then we call it as the equatorial line, means the line passing through the center and perpendicular to length of the magnet. It is known as the equatorial line, isn't it? Now here, this is the magnet and this is the magnetic line, isn't it? And this is the center. The line, isn't it, passing through the center perpendicular to the length of the magnet. That is called the equitorial line. Now, this is the line, isn't it, which is passing through the center and perpendicular to the magnetic length. That is called as the equatorial line. This is one. And the second is here, the point which will come across in the derivation of this one is regarding the vectors. Now here, regarding the vectors, isn't it, already we have studied in detail in PUC level, and what it is the moreover in what it is the in the degree level also, isn't it, semester, etc. Then such is what it is the a basic what it is the topic in the mathematics. Then here, see, whatever the point is necessary, isn't it, then which will come across in the derivation of this what it is the formula, only that point I want to make it clear. Now, in the lower classes, you have studied that the how to find the what it is the resultant vector. Is it resultant vector? Then, in case of the two, if you are having the two vectors, how to find their resultant vector? Isn't it? How to find the resultant vector? Then, you see, in the previous derivation, we have observed that if the two vectors are, in the same direction, isn't it? Now let us see, this is what it is the A bar and this is the B bar, isn't it? Then the resultant of these two, it is R bar, it is equal to A bar plus B bar, isn't it? Like this one. Now suppose if they are in the opposite direction, isn't it? Then this is A bar and this is B bar. Resultant is equal to A bar minus of B bar, isn't it? And the next is here, suppose if they are inclined by some angle, isn't it? Let us say this is A bar and this is B bar. The resultant of these two can be determined by using the law of parallelogram of the vectors R bar. Now in this case, R bar is equal to A square, what is square root of A square plus B square plus what is 2AB cos theta. This is the formula what we use it here. Now the next here, the one more case is, isn't it? Then we'll adopt, isn't it? For the determination of the resultant of any two vectors, we use the method of the resolution of the vectors also, isn't it? Now see, these are the different methods we use for the determination of the resultant of any two vectors, isn't it? One is what? If they are along the same direction, this is the formula. Then if they are in the opposite direction, then this is the formula. And if these two are inclined at some angle, this is the formula. And one more method for the determination of the resultant of any two vectors is nothing but it is a method of resolution of the vectors, isn't it? Now, what is the resolution of the vector? Isn't it? Now, carefully you see here. Suppose if you are having the any what is the vector R bar, then this is resolved or this is split into two components, isn't it? Then here, suppose this vector makes an angle theta with this axis, isn't it? Then let us say this is O, isn't it? And this is X and this is Y. And then its X component we say, isn't it? X component, isn't it? Rx, it is equal to what we here? R cos theta. This is Rx square, isn't it? Along the X direction, its value is equal to R cos theta. And what it is along Y direction, Y component, isn't it? Rx is then Ry is equal to R sin theta, isn't it? That means if you are having the any what is the vector, now that vector can be what resolved, means split into two components, isn't it? And this is the X component and this is the Y component, isn't it? What if this vector, carefully you see here, if this vector makes an angle theta with this axis, then this we call it as the X component and this is called as a Y component. Then X component is what it is the Rx is equal to R cos theta and Y component is what it is the Ry is equal to R sin theta, isn't it? Then this. And suppose in some cases, isn't it? In some cases what will happen is if this vector makes an angle theta with this axis, isn't it? And then this will become as the R cos theta, is it? And this will become as r sin theta. Now, when it is, if this vector makes an angle theta with this axis, then this will be r cos theta and this will be r sin theta. Are you followed? This is the important one. I think this you have studied in the lower classes, but you might have forgotten, so that I had made it clear. Once again, I repeat here: if this vector makes an angle theta with this axis, isn't it? Then this will become as r cos theta, other will become as a r sin theta. Now, instead of like this one, suppose if this vector r bar makes an angle theta with this axis, then this will become as r cos theta and this will become as the r sin theta, isn't it? Now, you see, these are the important points what we come across in the derivation of this one. Now, let us what it is try to understand this derivation, isn't it? Now, carefully you see here. Here, this is a what it is the magnet or two poles. Then pole strength of each pole, let us consider it is equal to what is the m, isn't it? M is the strength, and what it is the, this is the equatorial line. As I made it clear that the line passing through the center and perpendicular to the length of the magnet. This is the length of the magnet, and this is the line which is passing through the center. This is called as the equatorial line. Now, P is any point, isn't it, at a distance of d, isn't it, on the axial line, on the equatorial line of the magnet. Isn't it? P is a point which is at a distance of how much it is a d it is, isn't it? Then here, now see at this point what is the P? Again, what it is the, there are the two fields are acting, isn't it? Then at this point, what is the P? There are what it is the two fields are what it is the acting, isn't it? Then one is what? Then one is due to the north pole and another is due to the south pole, isn't it? Now, field due to the north pole, isn't it? Field due to the north pole, it is what is equal to what you get it here. This is a point, you get it here. This is a point. Then field due to the north pole is what it is the mu naught divided by 4 pi. Then m divided by the square of the distance of the point from the pole, isn't it? Then this is the what a field due to the north pole, isn't it? Now, what is the value of field due to the south pole? Isn't it? Now, field due to the south pole is nothing but then here you will get the what is the field due to the south pole, you get it here, is what is equal to the same, then pole strength is same, then distance of the point from the south pole is nothing but it is a sp square will get, isn't it? Now, this is the what is the value of field due to the north pole at this point, and this is the field due to the south pole it is, isn't it? And the next is that here you will get since this one it is a vector which has the magnitude and direction, isn't it? Then here this is giving what is the magnitudes. Then what about the directions? Here, then since this is the north pole, isn't it? Then field due to the north pole is what it is away from it, means it is in this direction, isn't it? Then this is the south pole, field due to the south pole ds is what is this one in this direction. Field due to the north pole here, value is this much, and field due to the south pole here, it is equal to this one, and their directions are, since this is the north pole, field due to the north pole is away from it, and field due to the south pole is towards it. Then, here, looking to this figure, is it a, tell me what is the value of NP and what is the NS. Now, see, this is like a, what is the right angle triangle, isn't it? Therefore, square of this, is it a NP square, it is equal to what we get it here, B square plus what is the, this total length is 2L, then this will become as what is the L. Therefore, square of this NP square is equal to D square plus L square, isn't it? Then for the NP, it is equal to under root of this one, isn't it? Now, NP value and NS value, it is what is the same, isn't it? Even you can see that NS square, it is equal to what is the D square plus L square, and NS is equal to square root of that, isn't it? Now, since here B Bn is equal to Bs, isn't it? Since this, what is the Bn? Sorry, not Bn, it is a Np. Is Np and what is the Sp is Sp Np square Sp square. Then Np and Sp is. Now here Np value is equal to Sp value, isn't it? If these two values are same, means you can see that remaining factors are same, so that Bn is equal to what it is the, you will get Bn. Therefore, of Bn it is equal to what it is the Bs. Feed into the north pole and feed into the south pole, it is what is the same. Its value equal to this much, you get it. Okay. Now see, after understanding this one, yeah, how to find the resultant of these two, is it a vectors? Now here, this B, what is the Bn and Bs, they are not what it is the in the same direction, they are inclined, is it? Because Bn is like this, is it? And Bs is what is the like this one. Then they are inclined. Then if they are inclined, then we use the method of what is the resolution of the vectors, is it? Then first, let's say this is the vector. Then this is resolved into two components. When you take the coordinate system like this, isn't it? Now this vector makes an angle theta with this axis. Then since this vector is making an angle theta, isn't it? This one with this axis, therefore this will become as a cos component and this will become as its sin component. This is the value of what is the theta. Then cos component is what is the Bn cos theta and this is Bn sin. Similarly, this Bn is also be resolved into what is the two components, isn't it? Then you take the coordinate system like this for this one. You take the coordinate system for this vector like this one. Now this vector, it is what it is the making an angle what is theta with this axis again, isn't it? Now this vector makes an angle theta with this axis, means then this will become as its cos component and this will become as its sine component, isn't it? Now again you see here, this is the vector Bn and this is the vector Bn. Now these two are what is the inclined by some angle, so that to find the resultant we use the method of resolution of the vectors, isn't it? First, this vector, it is resolved into two components. First you take the coordinate system like this one, isn't it? X and y axis, and this vector makes an angle theta with this axis. Therefore, this will be its cos component and this is its sine. Now coming to this vector Bs, isn't it? Now this, if you want to resolve this one, again you take the coordinate system, isn't it? This like this. Now this vector makes an angle theta with this axis, isn't it? Therefore, then this will become as its cos component, that is Bs cos theta, isn't it? And this will become as its sine, isn't it? Now looking to the figure, yes, here Bn is equal to Bs, isn't it? Now here sin theta, Bn is equal to Bs. Now these two are, isn't it, equal and opposite direction is same, isn't it? Equal and opposite, therefore the resultant value will be equal to 0, isn't it? That means if you consider this is what is the phi and this is equal, but opposite means you must take minus, isn't it? Plus phi minus phi, that is equal to 0. That time, if the two vectors are, isn't it, equal and opposite, that to be what it is, in such cases the resultant is what is the 0. Then resultant of these two, it is 0. They will, now remaining is what here? Remaining what it is the Bn cos theta, another is what it is the B, what it is the S cos theta. Now both are in the same direction, isn't it? Therefore, if the two vectors are in the same direction, then the resultant of those two vectors is sum of those two, isn't it? You must add. Therefore, the resultant field at P, it is equal to, isn't it, then Bn cos theta plus what it is the Bs cos theta. Again, since Bn is equal to what is the Bn, therefore both are same, you have to add it. Therefore 2 times will get, isn't it? Therefore 2Bn, what it is the cos theta will get. Therefore this is equal to 2 unit as it is, and Bn value it is equal to this much. isn't it? And cos theta, then cos formula is what? Cos formula is equal to adjacent divided by hypotenuse. Then adjacent value is L, isn't it? Then hypotenuse is what it is, the NP, isn't it? Now, yes, you know that NP or NS is equal to square root of D square plus L square, isn't it? Now, this is square root. We will get this is the value of cos theta. Now, you simplify this one, then this 2 I have taken it here, mu naught divided by 4 pi, isn't it? And what is the 2 here? And next m is same, the L is same. Then its power is how much it is? Then nothing is there, means 1. And root means it is half, isn't it? Now, base same means power should be added. Therefore, when you add power 1 plus half, it is nothing but it is equal to 3 by 2. Isn't it? Now, this is what we get here. The next point is here, this BE is our resultant field on the equatorial line. BE is equal to this mu naught by 4 pi, that I will take as it is, isn't it? Mu naught divided by 4 pi. And 2L into M is nothing but it is magnetic moment, capital M. Isn't it? This one. Then divided by, you will get it here, D square plus L square whole raised to 3 by 2. Isn't it? Now, this is what the formula of the magnetic intensity at any point on the equatorial line of a magnetic dipole. Now, as we have discussed it in case of the axial line, special case, in the same manner here also, is it a special case? Is that what the special case means? If the what is the L is, that is length of the magnet, is very much less than D, that means for a short magnet, you will find that what means here in this case, now I will write it here as BE, it is equal to, then what we get, this mu naught divided by 4 pi as it is, isn't it? Mu naught divided by 4 pi, isn't it? Then M also you write as it is divided by, then what you do is you take out D square out of the bracket. Now D square, then its power is how much here? 3 by 2. This as it is. Now this one you will left with 1 plus L square divided by D square is to 3 by 2. Isn't it? Now here you can see that the from this, what it is the bracket, when you take out D square, then power it is there 3 by 2, that I have written it. And when you take out this one, you will get 1 here plus this will come to the denominator. This is what you get it here. Now, what is L divided by L is very much less than what the D means. Numerator value, it is very much less than the denominator. What will happen is this value is almost to become 0. Isn't it? Now, this will reduce up to what it is the mu naught divided by 4 pi. M I will take as it is divided by, then when you apply this power, 2 will get cancelled, you will get dq, and this is approximately 0, leave it. Then 1 you left, 1 raised to 3 by 2 is 1, therefore 1 into this you will get this one. Therefore, this is the formula of the magnetic intensity at any point on the equatorial line of a short magnet, isn't it? Now, this is the general formula, and this is for what it is a short magnet, isn't it? Then here, this what it is the formula you get it. Then after getting this one, isn't it? Now, when you compare, isn't it, the field on the axial line and the equatorial line, let us see what relation you will get it, isn't it? Now, field along the axial line, you go through this one that already we have derived it. Then its value it is equal to mu naught divided by 4 pi. 2m is there. 2m divided by dq. Now you can write this as what is the this 2 times what is the this also be equal to, you will get what means, then you can write this as mu naught divided by 4 pi. Then otherwise this you write first you write 2 mu naught divided by 4 pi m divided by what is the dq, isn't it? 2 I have taken it here. Now this is equal to 2. Then mu naught by 4 pi into m by dq is what is the BE, that is the field along the equatorial line. Now this shows that field along the axial line is twice the field along the equatorial line. That means Here, feed along the axial line is 2 times or double the feed along the equatorial line. Means always the feed on the axial line is more than that on the equatorial line. Now, see, this is a relation between the feed along the axial line and the equatorial line. This one. Now, see, this is what the derivation we got. And once again, you see here, then first thing is that to which we call it as the equatorial line. That means equatorial line, it is the line passing from the center perpendicular to its length, isn't it? Now this line, it is known as what it is the equatorial line, isn't it? And here field due to the north pole at this point, isn't it? Its value is equal to this much, isn't it? Mu naught by 4 pi m by square of the distance is m3 square. Its direction is like this one. And field due to the south pole is mu naught by 4 pi m divided by what is the s square. Its direction is, since this is the south pole, field due to the south pole is like this one. Now these two, what is the fields, that is the vectors, they are inclined. To find the resultant, we adopt the method of resolution of the vectors. Like means this is divided into two components. This is divided into two components. Is it a? And this and this, they are equal and opposite. They cancel together. And what is the Bn cos theta and Bs cos theta? They are along the same line. Hence, the resultant is you will get what is the response. This is what the derivation. After deriving this complete, now finally we comes to conclusion that the field along the axial line, it is what is the twice the field along the equatorial line. Now see, these are the two important derivations concerned to what is this topic. Now I will stop here and the next point we will discuss in the next lecture. Thank you. Thank you.